See this problem. A 10 ohm thick wire is stretched so that its length becomes 3 times. Assuming that there is no change in its density on stretching, calculate the resistance of the stretched wire. So our motto is, there is a conductor with some cross-sectional area A1 and length L1 with a resistance R1, and you are stretching that wire in a manner like that is the length of the conductor is going to be increasing, and it is L2, and the area of cross section of the second one is going to be decreased, that is A2, and the resistance is R2. We need to find out the resistance of the stretched wire, so we need to find out R2. That is our motto. So now I am going to investigate the things. So what are the quantities that I have given? First of all, R1 is equal to 10 ohm, A1 is equal to, so we don't know it, let it be A1 only, A1. So L1 is equal to, let it be L1, and R2 we need to find out, and A2 also let it be, we don't know. But L2 is equal to, that means you are stretching the wire in such a manner that the length of the wire is going to be triple, like 3L1. You have previous length as L1, after stretching it is become thrice of the previous one, that is 3L1. so these are the given quantities. Now I am going to resolve the problem. So first of all, I am finding the volume of the first conductor. Volume of the first conductor V1 is equal to area of cross section into length of the conductor, as well as second one volume is also V2 is equal to area of the second conductor into length of that conductor. And at the same time, R1 is equal to rho into L1 by A1, R2 is equal to rho into L2 by A2. Why I am writing rho here? Because it is the same material, so resistivity is same for those two. And after that I am converting this expression to volume expressions, like R1 is equal to rho into L1 by A1. I am multiplying L1 for the numerator and denominator like this, and here also R2 is equal to rho into L2 by A2. Here I am multiplying L2 for the numerator and denominator, that is equal to A1 L1, it is the volume of the first conductor, A2 L2 volume of the second conductor, that is equal to rho into L1 square by V1. Here also rho into L2 square by V2. If you see the problem once again, there is given like assuming that there is no change in its density on stretching. So that means density is not going to be changing. What is density? Density is equal to mass by volume. If density is constant and you are not cutting the wire also, so mass is also constant, that means volume is also constant. If volume is constant, then V1 is equal to V2. Now I am taking the ratio of these two resistances R1 and R2. So R2 by R1 is equal to, finally the row will be gets cancelled, so I will get L2 square by L1 square. That is equal to, what is L2? It is 3L1 whole square by L1 square. That is equal to, finally we will get 9. Then R2 is equal to 9 into R1, where R1 is equal to 10 ohms. So 9 into 10 ohms gives 90 ohms.